Okay, Gen Chem kids, we are going to do the Bohr model of the atom today. So you are going to want to have a periodic table nearby. And also, just to help you understand what's going on, you're going to want to grab a periodic table as well. Okay, you might want to have some colors nearby as well, just because the notes tend to get a little mismatched into each other. So I'm going to try and change color every other line so that we can keep things straight. Okay, so we're going to look at elements one by one. We're going to build up from the first element down to probably the 20th or 30th, somewhere around there, to hopefully help you understand a pattern of what's going on. So the very first element on the periodic table is hydrogen. So when we look at hydrogen, the thing that we're really looking for is this. We are looking for how many protons it has and how many neutrons it has and how many electrons it has. So really protons and electrons. We're going to say that we have matched or neutral atoms today. So when I say matched or neutral atoms today, that means that we're going to have the same number of protons and electrons. So hydrogen here has one proton, so we mean we're also going to have one electron. And we're in the first row of the periodic table. So if you remember, rows on the periodic table are called periods. And that corresponds to energy levels. So if I'm in the very first row, like I am with hydrogen, I only have one energy level in that atom. So one. So we're going to draw one energy level here, and I'll show you what I mean. So here, let's get to my drawing tools. Let's get a color. So hydrogen, I've got a total of one electron here. So in the Bohr model, we're going to put a little dot here in the middle, and we're going to have one little circle, meaning that that's one energy level. And I'm going to try and make that circle a little bit nicer so that I'm not a very good line drawer. Okay, that still didn't work very well. So I'm going to put one electron right here. So one electron on the first energy model. Now valence, we haven't really done this vocabulary word yet. Valence means electrons on the outermost shell. So the outermost shell is the outer energy level. So I only have one energy level here, and that energy level only has this one little electron here. So I have one valence electron. So for the dot picture here, when we do a dot picture for Lewis, we take the element and then we kind of place the electrons around it, depending on how many electrons we have in that outermost shell. So that outermost shell, we have one electron. So we're going to take the symbol for hydrogen, and we're going to put one dot next to it, showing that it has one valence electron. Okay, let's move on to helium. So when I look at helium, I've got two. I should switch this back to a highlighter. I've got two electrons there, two protons, two electrons. Okay, so now on your homework, I'm going to ask you to also find neutrons. So for example, if I have a mass of 4, how do I find the neutrons? If you remember correctly, the mass here, 4 minus 2, will give me the neutrons. So 4 minus 2 will give me 2 neutrons. So you're going to need to do that in your homework. But for this, we're going to just look at the electrons. So helium, I've got 2 electrons, and we're still on that very first row of the periodic table. So I'm still on that first energy level. So I've got 1 and 2 electrons in that first energy level. So I've got these 2 electrons on the outermost energy level, so I will have 2 valence electrons. So when I make helium's dot picture, I'm going to show 2 dots because I have 2 electrons on that outermost energy level. Okay, let's look at lithium. So now if I go to lithium, I'm going to change my color just to keep it straight. If I go to lithium, I am now on another row. And notice it's the second row. So I now am on the second energy level. So I now am on energy level 2. Notice these numbers here go with the energy levels, okay? So I'm on energy level 2. So that means I'm going to have 2 rings of electrons. Now in that first ring, I'm going to have electrons 1 and 2. That third ring, I'm going to have the third electron. Okay, so let's draw this out. So lithium gives me 3 total electrons. The first energy level, I have the electrons from helium and hydrogen. But that second energy ring, I'm going to have that third electron from lithium. Now remember, the valence electrons only go with that outermost ring. And I only have that 1 electron on this outermost ring. So I have 1 valence electron. So in my Lewis dot picture, I am going to show lithium with just 1 dot because I only have 1 valence electron. Okay, let's look at beryllium. So beryllium, I now have 4 electrons. I'm still on that second energy level. So here we go. Oops, wrong thing. So beryllium, 4 electrons. I'm on that second energy level. The first 2, and then the second 2. And really, you can draw your electrons wherever you want on their respective energy levels. So I have 2 electrons on that outer ring. So I will have 2 valence electrons. So when I draw beryllium's dot picture, I am going to show that beryllium has 2 electrons in its outermost ring. Okay, let's go on to boron. So if I look at boron, I now have 5 electrons, but I'm still in that second energy level. So that 5th electron is going to go on the second energy level. So here we go. 5 electrons for boron. That first energy level is just going to have 2, and then the second energy level is going to have 3. So I have 3 valence electrons, 3 electrons on that outermost energy level. So for boron, I'm going to show that I have 3 dots, or 3 electrons in my valence shell. Okay, let's do carbon. Carbon, 6 electrons. I'm still in that second energy level, so that 6th electron is going to go on that second energy level again. So 6 electrons. I'm going to have my nucleus, my first 2 electrons from hydrogen and helium, then lithium and beryllium and boron, and now carbon. So I will have 4 electrons on that outer ring. So I will have 4 valence electrons, which leads me to write my carbon with 4 dots around it, showing that I have 4 valence electrons. Okay, let's look at nitrogen. Nitrogen, hopefully you see a pattern here. Nitrogen has 7. It's still in that second energy level, so I'm going to put that 7th electron on that second energy level. So 7 electrons here. My nucleus, my first two on that first energy level. So 1, 2, 3, 4, 5, 6, and 7. Okay, so that gives me 1, 2, 3, 4, 5 electrons on that outer energy level, which means that my dot picture for nitrogen, I'm going to show 5 electrons, or 5 dots around the nitrogen. Okay, phosphorus. Phosphorus, or not phosphorus, oh, it shouldn't be phosphorus. It should be oxygen. So let's change that to oxygen. So we're going to change this to oxygen. We have 8 electrons, not valence electrons, but 8 electrons. I've got my 2 on my first energy level, and I've got 1, 2, 3, 4. I need to make these big so you can see them. 4, 5, and 6. So on that outer energy level, I'm going to have 6 electrons. And this will give me, for my dot picture for oxygen, 1, 2, 3, 4, 5, 6 electrons in the dot picture to show me what is on the valence. Okay, fluorine. Let's look at fluorine. I have 9 electrons. I'm still on that second energy level. So 9 electrons, second energy level, first 2, 3, 4, 5, 6, 7, 8, 9. Okay, so on that outermost ring, I have 7 electrons. So my dot picture for fluorine is going to show those 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. Okay, I bet you can probably predict neon. Neon, we're still in the second energy level. We have 10 electrons. So let's look at this. 10 total electrons. We've got 2 energy levels. So the first 2 right here, 3 and 4, 5, 6, 7, 8, and 9 and 10. So that gives me 8 electrons on that outermost shell. So when I look at neon, I'm going to have 2 electrons on each side, or 8 total valence electrons. Okay? Now, let's look at, notice it's all full. So let's look at sodium. So when I go to sodium, let's switch colors here. Let's use this green. So if I go to sodium, I am now at a new level. So we're now going to have 3 energy levels, and I have 11 electrons. That last electron is going to be the first, that 11th electron is going to be the first to go on that 3rd energy level. So let's look at this, and I'm going to change my color again here. Let's make it another color. So sodium, I've got 11 total electrons. I've got 3 energy levels. I've got 2 electrons on my first. I've got 8. 1, 2, 3, 4, 5, 6, 7, 8 on my second energy level. And then on my 3rd energy level, I just have 1 electron. So remember my valence shell, this is my valence shell. My valence electrons is only my outermost level. At my outermost level, I just have 1 electron. So I'm going to draw sodium with just 1 electron. Okay, let's go on and do some more. Magnesium. So if I look at magnesium, I've got 12 electrons. Just 2 on that third level though. So magnesium, I've got 12 total electrons. My Bohr model, I've got 2 on my first level. I've got 8 on my second, so that gets me up to 10. And then I've got 2 on my outer shell. Remember, valence is just my outer shell, so I've got just 2 electrons there. So my dot picture for magnesium will give me just 2 electrons. Okay, aluminum, I now have 13. Okay, so 13 electrons. I'm going to put it over here. 2 here. 2, 3, 4, 5, 6, 7, 8 on the second level. And then on the third level, I will have 3. 1, 2, and 3. So 3 valence electrons for aluminum. So my aluminum dot picture will just have 3 dots by it. Okay? So I want you to see if you can do the pattern for the rest of those down to argon. Pause the video right now and see if you can continue on the pattern that we've done. And we're going to check in just a minute. Okay, you ready to check? Okay, silicon, as you probably guessed, we're going to add yet another electron. So 14 electrons. 14 electrons for silicon, which is going to, I'm going to put silicons right here. So 2 on that inner, 8, 1, 2, 3, 4, 5, 6, 7, 8 on the second. And that will give me 4 on the third. So 4 valence electrons, just the outermost electrons. So silicon, I'm going to have 4 dots. How'd you do? Okay, phosphorus, 1 more, 15 electrons. So 15 electrons for phosphorus. We're going to have 2 on the inner, 8 on the second, and 1, 2, 3, 4, 5. 5 on the third. So that's going to give us 5 valence electrons. So phosphorus will have 1, 2, 3, 4, 5 electrons on its dot picture. Okay, sulfur, 16. So let's take a look. 16, I'm going to put it over here. We've got 2, and then 8. And then we're going to have 1, 2, 3, 4, 5, 6 to get our 16. So 2 plus 8 is 10, plus 6 more is 16. That will give us 1, 2, 3, 4, 5, 6 in our valence shell. So when we do sulfur's dot picture, we're going to show 6 electrons around sulfur. Okay, how'd you do on that? All right, chlorine. Chlorine, we're going to have 17. So here we go. 17, 2, and then 8, and then 7. Okay, so that will give us a grand total of 7 valence electrons, or 7 electrons on the outermost shell. So on chlorine's dot picture, we are going to want to show 7 valence electrons. Okay, and then argon, we've got 18. So let's do this. 18. So I'm going to put it right here. We've got 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8 plus 8 equals 18. That gives us 8 on our valence shell. So argon's dot picture, we will have 8. All right, let's do some more. Okay, potassium. Okay, so when we go to potassium, notice we are going to yet another row. So since we're going to yet another row, that means that we are, you guessed it, we are going to yet another energy level. So yet another energy level. So we're going to now have 4 energy levels here. Okay, so we are also going to have 19 electrons to place. So I'm going to change my color. Let's do that. Okay, so 19 electrons. 1, 2, 3, and 4. So the first energy level, we're going to have 2. Second, we'll have 8. Third, we will have 8. And then the fourth, we will just have 1. Okay? So in terms of our valence electrons, we will have 1 valence electron. So that means our dot picture for potassium will just have 1 dot. Okay? Calcium. Probably have seen a pattern here. We've got 20. So we're going to add yet another electron. So calcium, we've got 20. We're going to put our picture right here. 1, 2, 3, 4, 5, 6, 7, 8. For this, 1, 2, 3, 4, 5, 6, 7, 8 for our third energy level. And our fourth energy level, we will just have 2. So this will give me 2 valence electron. So that means that calcium will just have 2 electrons here. Okay, gallium. Ooh, we're going to skip over these. So we're not going to do what we call these transition metals. We're going to do straight over to gallium. Okay, so when we go straight over to gallium, we're going to do 31 electrons. So that's 31. Where did those 10 in between go? Yeah, yikes. They actually went into the third energy level. So it gets kind of confusing here. So 2 on the first energy level, 8 here. One, 2, 3, 4, 5, 6, 7, 8. And then remember for calcium, we had the first 2, 1, 2, and then we had 10 in that transition metal block. Those 10 do a weird thing, and it's due to quantum mechanics. And I'm not going to explain quantum mechanics, but when we go over the transition metal block, those electrons actually go in on the second energy level. So we have the 10 electrons showing up there on the, not the second energy level, but the third. And then once we get to gallium, that block there, it goes back up to the third. So, or to the fourth energy level. Oh my gosh, I keep misspeaking. The fourth energy level. So we will have 1, 2, 3 electrons on the valence here. 3 valence electrons. So gallium, we will have 3. Calcium, did that not take? Okay, germanium. Let's look at germanium. We now have, yeah, it didn't take, we have 32 electrons. So you'll probably notice that each of these in this column have 4 valence electrons, right? Have you noticed that yet? So let's look at this. So germanium, we're going to have 32 valence electrons, or 32 total electrons, not valence electrons. So 2 in first, 8 in the second. We'll start off with 8 in the third. And then we jump to the fourth and we get the first 2 put in on the fourth. And then those 10 electrons from the transition metal groups kind of come in. Is it going to let me switch to green? I would like to switch to green. There we go. The 10 transition elements. So there's 6, 7, 8, 9, 10. Then let's switch back to purple. Then we will have galliums and then germanium. So that will give us 4 valence electrons. So germanium's dot picture will look like this. 1, 2, 3, 4. Okay. Arsenic. We are going to have 33. Probably you remember, we're just going to go up by 1. So here we go. 2, and then 8, 8 more on the third level. And then we get the first 2. And then we do that transition metal block again. And those come in on the second or on the third energy level. Okay, so the 10 will come here. I guess it's not going to let me switch to green. And then we add the 3 that we get for arsenic. 1, 2, 3. So arsenic will have 5 total valence electrons, which will give me that kind of a picture. Okay. All right, selenium. Selenium, let's look at our periodic table again. So arsenic, selenium, 34. Here we go. 34. 34 total electrons. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we had our first 2. And then our transition metals would come in. And we'd put in the 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we will put in the rest. 1, 2, 3, 4. So selenium will have 6 total. 1, 2, 3, 4, 5, 6 valence electrons, which will give us a dot picture. 1, 2, 3, 4, 5, and 6. Okay, bromine. You've probably guessed it. We have 35. So let me switch colors if it will let me, just so that it doesn't get so confusing. Okay, bromine. Oh my gosh, this is too thick. First level, second level, third level, fourth level, and then the 10 transition metals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we will go and add the 1, 2, 3, 4, 5, 6, and 7. So this will give me 7 valence electrons for bromine. So I will have 1, 2, 3, 4, 5, 6, 7. Okay. And then krypton. You probably are well aware that we are just going to add one more electron here. So 36 for krypton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total. 11, 12, 13, 14, 15, 16, 17, 18. Then we do the fourth level. 1, 2, and then the 10 transition metals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have to add in the 6. 1, 2, 3, 4, 5, 6. So that will give krypton 8 valence electrons. So krypton's picture is going to have 8 electrons around it. Okay? All right. So hopefully you understood that each row on the periodic table is an energy level. And every time we added another electron, we added an electron on that energy level until we switched rows. So hopefully you have a fairly good idea of how to draw the Bohr model. If you have any questions, please email me. Good luck on the homework. Thanks. Bye.